Hello everyone. Today we'll be discussing the configurations of biphenyls. By definition, biphenyls are compounds that have two phenyl groups linked to each other. In other words, they are made up of two benzene rings joined to each other by a single covalent bond. This is the phenyl group, this is the benzene group, and this is the biphenyl. In the biphenyl, we have the ortho position, the methyl position, and the para position. Biphenyls with substituents at ortho position are called atropisomers. This is an example of biphenyl having substituents in an ortho position. These two biphenyls, they are regarded as atropisomers. These atropisomers, they are stereoisomer, which arises due to restricted rotation about this diphenyl single bond. This restricted rotation about the diphenyl single bond prevents interconversion of the isomers and therefore making it easy for you to isolate this stereoisomer. Another important information we have to derive from this atropisomer is that if the atropisomers are non-superimposable mirror images, the bond with restricted rotation is called the axis of chirality. So, having known what atropisomers are, let us now consider steps in determining the configurations of biphenyl compounds. The first step in determining the configuration of biphenyl compound is to create a pseudo-tetrahedral representation of the biphenyl. So, in the pseudo-tetrahedral representation, we prioritize the first group in the first ring. This first group in the first ring is represented with a vertical line, while the second ring at the back is represented with a dotted horizontal line. The next step is to assign priority, starting with the vertical line. As earlier stated, the vertical line is prioritized over the dotted horizontal line. So I'm going to assign my priority starting with the vertical line first before I can now extend my assignment to the dotted horizontal lines. After the assignment of my priority, then I will move from substituents with the highest priority down to the other lower prioritized substituents. The position of the least substituent is insignificant. Therefore, the configuration of this biphenyl is S configuration. Let us consider the configuration of the mirror image of this biphenyl just illustrated above. This is the pseudo-tetrahedral representation of the biphenyl above. This is the mirror image. The mirror image is actually gotten just by changing the substituents in the horizontal dotted bond. As earlier discussed, this biphenyl has an S configuration. In the mirror image, we have also assigned their priority. Then, determining the configuration, we move from the substituents with the highest priority down to substituents with the lowest priority without taking cognizance of the substituents in the least priority. In moving my arrow, I will move in this direction, which is R. Generally, if you know the configuration of a biphenyl, the mirror image will have the opposite configuration of that biphenyl. Let's now consider another example. Let us consider how to determine the configuration of the biphenyl. In step 1, I just redrew the structure of the biphenyl. The structure in step 1 and the biphenyl represented in the example 2 are the same thing. I just redrew the structure of the biphenyl. In step 2, when viewed in the direction of the first biphenyl ring, we have the substituents in the first ring in the vertical axis, while the substituents in the second ring are represented in the horizontal axis with a dotted line. In step 3, We assign priorities by first of all prioritizing the substituents in the vertical bond. In the horizontal dotted bonds, oxygen takes priority over carbon, so that is why oxygen is assigned 3 and the carbon is assigned 4. So here we can comfortably take our configuration, which is the R configuration. Thank you for listening to my video. Please like, subscribe and share. If you have any question regarding to what I just discussed, please leave your questions in the comment section. Thank you.